In this video, we will determine the radius of a circular pizza with each of the given areas. We will round our answers to 2 decimal places if appropriate. As a reminder, we should remember that the formula for the area of a circle is that the area equals pi times the radius squared. In part A, we are told that the area is 36 pi square inches. To find the radius of this pizza, we need to substitute 36 pi in for the area in the area formula. So we'll end up with the statement that 36 pi equals pi r squared. To solve this equation, we first need to isolate the squared variable component, so we need to get the r squared by itself first. To do this, we'll take our equation 36 pi equals pi r squared and divide both sides of the equation by pi. Once we divide both sides of the equation by pi, we'll end up with the equation 36 equals r squared. To finish solving this equation, we will use the square root property, where we know that if r squared equals 36, then either r equals the square root of 36, or r equals the negative square root of 36. Simplifying both of those two equations, we either end up with r equals 6, or r equals negative 6. Technically, this equation does have 2 solutions, 6 and negative 6. But working in the context that we're in, where we're talking about the radius of a pizza, we cannot have a radius that is a negative distance. So we can immediately eliminate negative 6 as an answer for the question. Ultimately, the question is, what is the radius of this pizza? Of these 2 answers, only the positive 6 is the one that makes sense. And so we'll simply make the statement. The radius of this pizza is 6 inches. In part B, we are given that the area of this particular pizza is 1,612 square centimeters. Again, we'll start the same way. We know the 1612 square centimeters is the area, so we'll substitute that in for the a in the equation. So this will give us the equation 1612 equals pi r squared. In fact, most of the solving we're going to do will be an exact duplicate of what we just did. The only difference is because we started with a different value, the end result will be a different answer. So we'll begin again by trying to isolate the r squared, and to do that, we need to divide both sides of the equation by pi. So we'll take our equation 1612 equals pi r squared, and divide each side by pi. On the right side of the equation, pi r squared divided by pi will simply become r squared. Over on the left side, I will leave 1612 over pi as 1612 over pi. I will not try to approximate it at this point. Typically, we don't want to round in the middle of solving an equation. We'll save that as the final step if it's necessary. But we're back at a place where we have a variable squared equals a number. So if r squared equals 1612 over pi, then r either equals the positive square root of 1612 over pi, or r equals the negative square root of 1612 over pi. Now the fact is that pi does not divide evenly into 1612, and so at this point I will need to make use of a calculator, and I will be rounding my answer to 2 decimal places. So in my calculator, I will simply type in the square root in parentheses of 1612 divided by pi, and once I type that in and hit enter, my calculator says that is about 22.65. Over on the other possibility, where r equals the negative square root of 1612 over pi, the square root of 1612 over pi will still come out to be about 22.65. The only difference is that will be a negative, but it will still be an approximation, so I'll still use the approximately equal to symbol. Again, we're back in a situation where our equation does have 2 solutions, but not both of them make sense. Anytime you're dealing with the length of a real-world object and you come up with a negative possibility, you can immediately exclude that one and say the only one that makes sense is the positive. So as a final conclusion, the radius of this pizza is about 22.65 centimeters.